طيب السلام عليكم. So we're still in chapter 4. We discussed last time the data link layer, and we said that the data link layer is the only layer that's subdivided into two sublayers, the logical link control and the MAC layer. So today, inshallah, we're going to talk about the MAC layer or medium access control. And as we said before, medium access control is responsible for controlling the access to a shared medium. So the best way to understand the MAC layer, the MAC sublayer, as we said before, is to try to imagine some examples from real world. Any example from real world that involves, a group of people or group of entities are sharing a shared medium. Like for example, if we are in a meeting, we are sharing the floor of the meeting to try to have some efficient conversation. So we cannot just all of us can talk at the same time because this will not be efficient. So we have to take turns, or we have to organize the floor of the meeting, one by one, in order to have efficient conversation. Also, another very common example is if you have, on the street, if you have like a group of cars are trying to go through some intersection. So this way, these cars, they share that intersection somehow. So they have to, again, have some kind of mechanism to organize the access to the intersection or to the roundabout. So one car only can be in the roundabout at any point of time. So they have to also organize how to access that shared medium. So there are two major factors based on which we can organize the access to that medium. There are two major factors based on which we organize that access to the medium. And I'm talking about data networks, of course. So when it comes to sharing a medium in data networks, what are the two factors that affect the control of the access in data networks? What are the two factors based on which we organize the access to any shared medium in data networks? Any volunteers? نواف تفضل. What do you mean by topology? It's done. Okay. ماشي يعني okay. ماشي. Number one, we call it physical connectivity. Physical connectivity. Okay, which is how are the nodes and the devices are connected using actual physical cables. This is very important. So how the nodes are connected using physical cables. Are they connected using switch, hub? Are they connected using straight through cables, UTP, STP, fiber optics, things like that? So we call that, as Nawaf was saying, we call this the physical topology. Okay, so the physical topology here describes how the nodes and the network devices are connected using physical cables. What type of cables? How are they connected point to point? They are connected using different configuration, as we will see in a minute. Okay, so number two is, as Nawaf was saying, is the media sharing. By media sharing here, we mean that, like, imagine if we have like 40 machines in a small geographical area. So now, if we have these 40 machines connected using one shared medium, like for example, like this, you have like one logical bus, as we will see. This is a logical bus, and we have all the 40 nodes are connected on this shared medium. It's like 40 cars are getting into the intersection and they are sharing that intersection. So you have a roundabout and it's like a big square, and all the cars are coming from all directions are coming into that roundabout. Of course, in that case, the level of sharing is high. And in that case, for example, if you have two nodes talk at the same time, what will happen? So there is a very high possibility that two nodes can talk at the same time, in which case there will be what we call collision, like two cars getting into the intersection at the same time. They will collide. And collision in data networks is bad, as it is in real life, or طبعا real life is more severe. But in data networks also, collision is not a desirable phenomenon, because it causes the fact that all the data coming from all these nodes, they will be wasted, and they will have to retransmit all these data again. So if you have 40 nodes are sharing one bus, is different from the fact that I would say, okay, so these 40 nodes, if I make them share the same shared medium, the level of sharing will be high, and the possibility of collision will be high, which means that the performance will go down. Okay, the performance will go down, and that depends on the priority of these nodes, whether this is like the CEO مثلا device is sharing the medium with all the other nodes in the company, or something like that. So instead of having 40 nodes share the same shared medium, we could as designers, as network designers, we could say no, we cannot have these 40 nodes share one shared medium, because this will make the performance low. Instead, what we will do is that we will have 20 nodes share one logical bus, one, and then another 20 nodes share another logical bus 2. Okay, so in that case, the level of sharing is a little bit lower, and the possibility of two people talking at the same time on each bus is lower, which means the performance is higher. But we need something here. We need something here to kind of connect these LANs together. What do we do? What type of device do we use to generate that logical isolation between LANs? Logical isolation between LANs. What is the type of device that we use in that case? عبد الرحمن تيسير, اتفضل. You have a guess? لا. So the hub or a switch is a data link layer. لا خلاص, ما هو احنا we could say the list of network devices and we choose. So the device, the network device that is used to create that logical isolation between two LANs, as we said before, is a router. A router is a network layer device. So it works from a higher level, and it can break or isolate two LANs from each other logically. Okay, so this is what we refer to as a logical topology. So unlike the physical topology, logical topology describes or shows in abstract way how the nodes can share the medium and deliver information over a shared medium. So if we have, as we said, if we have many nodes sharing the same shared medium, the possibility of collision will be higher, in which case the performance will go down. If we have low number of devices sharing the same medium, we have a lower level of sharing, in which case the performance will be higher, because the possibility of two nodes talking at the same time will be lower. It's exactly similar to if we imagine that we are in a meeting and we have like 100 people. Okay, we are in a meeting. The possibility of having like a mess situation where everybody talks at the same time, the possibility is high, in which case, again, we will not have any efficient conversation. Whereas if we are in a small meeting, 5 people, 6 people, or something like this, so we can organize the meeting more efficiently by having turns, or by having certain mechanism to organize the floor for everyone to talk and have access to that shared medium. So okay, so now we have the difference between logical topology and physical topology, and these are two very important concepts. These two, they affect the design of the MAC access control technique. So in order to understand this a bit more, we need to talk about some physical topology. So a very famous physical topology is to have a certain number of nodes, okay? And these nodes, they are physically connected together using possibly a switch, okay? So if we talk about a switch is a device that, tries to connect a set of nodes physically in one LAN. So switch actually constitutes a LAN, or actually multiple switches constitute a LAN. The only thing that separates a LAN from another LAN, as we said before, is the router. Okay, as long as the router is not in the picture, then we have one LAN, one big LAN. So the switch in that case is very similar in real life. Like we have a message coming to our house. So our house now is a geographical location which has many people living in that geographical location. So if we have a message coming to that location, okay, so this message will have to go to the one who is responsible for delivering this message, which in our case, which is the switch. So the switch is a data link layer device, which reads, as we said before, it reads the destination address of that message. The destination address here is a physical name. So imagine that this message is coming to our house. So now the message came to our house and it needs to be delivered to Amr. Amr in that case is a physical name that refers to a particular person. Say Amr is here. This is Amr, okay? So we don't know where Amr is in the house, okay? So one way of trying to deliver this to Amr is to send it to the switch. The switch in that case will read the destination address, and the destination address has the word Amr in it. So the switch will say, oh, okay, I know. The switch is like someone who can read the message, who can read what's on the letter and say, oh, okay, so I know where Amr is. He is in the kitchen. So I can deliver this physically by sending this message through that cable to reach to Amr, because I know Amr is connected on that physical cable. Okay, so this way I can deliver the message to Amr. Okay, so that's how the message gets physically delivered over a multi-access or a shared medium. So if all of us share that switch, the switch will have to deliver the messages based on the physical address. And remember, just the fact that we have a switch, it doesn't mean that we cannot have a situation where two people can send at the same time, and in which case the collision will happen. In which case the switch represents logically some shared medium. So all of us logically share that switch. Okay, so physically we are all connected to the switch, and logically we are all sharing a shared medium. So if I were to convert this, so this is the physical topology. So if I were to convert this to a logical topology, okay, so it's as if we have one logical bus, and I stress on the word logical bus because we have physical bus, and all the nodes are connected to it. So this is the logical topology that corresponds to the physical topology with the switch. Okay, so it's as if all of us are sharing a shared medium. We are sharing a shared medium, and we are all connected to it. So which means that if two nodes here talk at the same time, collision will happen. Okay, so in other words, the switch gets converted in the logical topology as a logical bus. Okay, so if you convert the physical topology to the logical topology, we have to know this, that you only have two options. You only have one option, sorry. You only have one option from the physical topology to the logical topology. Okay? So once I show you the physical topology, you have only one choice to show me what the logical topology that corresponds to it. If we try to reverse that operation and I give you this and I tell you this is a logical topology, okay? Give me the physical topology. So in that case, we have multiple choices. So from here to here, we have one choice. From here to here, we have multiple choices, okay? So why? Because the logical topology can now be realized in the physical world using multiple options. How? One of them is using switches, as we said, as we have shown here. So this logical topology can be realized in the physical world using a switch. Okay. Is there any other way? Yes, there is another way. There is something called physical bus where you can use coaxial cables and BNC connectors. Remember, we talked about BNC connectors last time, and you will see it in the lab. So you can actually use physical bus and again connect all the nodes to the physical bus, which actually matches exactly that physical topology, but in that case, not using a switch, in that case, using a physical bus. But in terms of the logical topology for both, it's the same. It's represented by the fact that you have a logical bus and all the nodes are connected to it, which means that collision might happen if two nodes are sending at the same time. Okay, so from physical topology to logical topology, you only have one choice, and in the reverse direction, we could have multiple choices. And this is in fact what happens in networks. In data networks, the designers, if I want to build a network like at QU, there is a network analyst or network designer. This guy, has like a bachelor, for example, in computer engineering, and he knows exactly the theory behind data networks and stuff like that. So he would say, now we have 300 nodes that are localized in a certain geographical area. So these 300 nodes, I can connect them using switches only. So I can connect switches together and make a combination and connect all of them in one LAN. Well, this is a very bad design, because if you do this, all the 300 nodes, they will share the same LAN, and in that case, the possibility of collision is very high because the level of sharing is very high. And in that case, you don't have any logical isolation between these 300 nodes. So it's better. It's a better design to say no. I will isolate each 100 nodes in separate LAN, and I will connect them using a router to provide some to provide some logical isolation between all these LANs, so that the level of sharing on each LAN is lower, and in that case, the performance will be higher. So we would just debate and have this design on a paper. So that's what we refer to as the logical topology. And then this logical topology will be given to a technician. Okay, I would give this to a technician, and the technician would say, okay, so how can I realize this logical topology in the physical world? I have multiple options in that case. I can use coaxial cables, I can use UTP, STP, what is the speed? I can use switches, hops, and so on. I have to use routers here, I have to use switches here, I have to use straight through cables, I have to use crossover cables. There are two types of cable configuration, which you will study in the lab at certain point. So I have multiple options to realize a logical topology in the physical world. واضح كده يا شباب؟ So that's the difference between logical topology and physical topology. So this activity in that case is very straightforward. So we have nodes. We have 4 nodes that are connected using a switch. So this is a physical topology, okay? And in that case, we want the corresponding logical topology, okay? So how many choices do we have here? Do we have multiple choices here, or do we have just one? Anyone can answer. Only one. So we have only one choice in that case. And as we said before, the switch provides a shared medium which logically is represented using a logical bus. So I have, it's as if I have one logical bus and all the 4 nodes are connected on this logical bus. So that's the logical topology that corresponds to this physical topology. Okay, so this means that if 2 nodes talk at the same time, collision will happen here. So I'm sharing one shared medium, but I can, if I want, I can deliver one message to one person in particular, let's say Amr, okay, by having the message containing the physical address of Amr, or I can send this message to a subset of these nodes using multicast, or I can send this message as broadcast to all of them. I have all the possible choices. However, I have to be careful because if 2 nodes send at the same time, the collision will happen and the performance will go down. However, it's for 4 nodes connected to a switch. This is very reasonable, and in real life, it's very reasonable to have up to like 20 nodes connected on the same switch. So in that case, it's an efficient design. ماشي؟ طيب. So that activity is straightforward. Now بقى, we have the logical topology, and we want the physical topology that corresponds to it. Now we have to know here that, let's say this is node A, node B, and node C, and node D. Okay, so we want to realize this logical topology in the physical world. Okay, so on one hand, we know that we can do that using multiple options. Okay, so we can use that using multiple options. And but these multiple options, they have to have certain conditions and constraints. For example, A can talk to B directly. Okay, A can talk to C directly, but A cannot talk to D, for example, and C cannot talk to B directly. So they have to go through B. If A wants to talk to D, it has to go through B. If C wants to talk to B, it has to go through D or A, and so on. Okay, so how do we realize this in the physical world? One choice, طبعا we have multiple choices here, but if you give me the configuration for a physical topology that can realize this accurately, I can give you the bonus. Or I can give you 1 minute to think about that, and then we can we can select one to answer. How do I connect the crossover cable? Okay, so I can have, like, for example, node A and node B, and use some kind of crossover cable. This is crossover cable, okay, to connect A and B. Okay, what and then what do I do with the rest, yani? All of them, yani? All of them? Okay, so this is C and this is D, and in that case, I can have one crossover cable like this, one crossover cable like this, one crossover cable like this. Do I connect this? Okay, so there's no crossover cable between A and D. Okay, طيب. So these cables are connected to what here on the on this device? Yeah, this is actually the crossover cable will be connected point to point between A and B. يعني بس اكتب اسمك. طيب, it's connected here. It's connected in the network card اللي هو network interface card, right? So one cable is connected. So how about the other one? How about this other cable? Can we connect two to the same network card? Or can we connect مثلا two network interface cards on the same machine? No. Okay, so we have network interface card 1, network interface card 2 on the same machine. Well, this is the only way we can have two point-to-point links like this. We have to do this. So each one will have to be connected. Each connector has to be connected to a network interface card. Yeah, so each cable will have to be connected physically to a network interface card. Each network interface card on a machine will have only one connection. Okay. The switch on the other side has 48 ports, but each network interface card on a machine has only one port, which is يعني هو ال RJ45 port. So if you take a look at your laptop has only one RJ45 port. Okay, so if we need to connect two cables like this, then we need to have two cards. Is it possible? Yes, it's possible. It's possible, but this is the drawback of this. Okay, طيب, so this is one way of doing it. Of course, as we said, there is no such cable طبعا, لأن احنا we will not allow A to communicate with D directly or C communicate with B directly. So if C wants to talk to B, it has to go through A. Okay, and going through A will have to go through two network interface cards, from network interface card 2 to network interface card 1. So that's one way of doing it. طيب, what is the other way بقى? Are there any other ways? جاسم اتفضل. رينج توبولوجي يعني ماشي. اسمك ايه؟ سوري. جاسم. ماشي يا جاسم، يعني I will consider it صح، بس هي يعني not accurate، بس ماشي يعني. A ring topology, sorry. A ring topology is like this. You have one cable, okay, that goes in a ring, okay, and this is A, B, C, D, and they go like this, okay. This is not accurate. Why? Because يعني if A wants to talk to D, it will not go through B. Actually, it will not go through B. It will go through the ring to reach D. ماشي. But it will go directly through the ring, يعني not through B. But ماشي يعني it's inaccurate representation of the physical topology. But another يعني physical topology that can realize this logical topology accurately actually is not through crossover cables. If I have straight through cables مثلا in the lab, I don't have crossover cables. What do I have to do? Well, if I use switches here and switch here and switch here and a switch here, okay, each of these cables will be straight through cable, okay, because straight through cables are used to connect two devices of different type, a node to a switch, or a switch to a router. ماشي. If I connect two nodes of the same type, then I have to use crossover cable. You will study this in the lab in more details. So in that case, I can use switches. طبعا هتقول لي this is not an efficient يعني physical representation because I use 4 switches. Yes, it's not efficient, but if you only have straight through cables in the lab, this is the only way you can connect these nodes in that particular logical topology. Okay, so in that case again, A will have to talk to B, and A can talk to C, but A cannot talk to D, and so on. So you have multiple ways you can use cables. These cables could be coaxial, could be UTP, could be STP, could be fiber optics. You can, depending on the speed requirements and so on, you can change the physical topology as you see fit, right? But in brief, to realize the logical topology in the physical world, we could have multiple options. But in the reverse direction, we only have one option. ماشي كده؟ طيب. Now we have a complicated physical topology that we need to convert to a logical topology. So the first question is, how many choices do we have? Only one choice. صح. تمام. Okay. طيب. The second question is, how many lands do we have in this very complicated physical topology? How many lands do we have? محمد عبد الله اتفضل. لا. How do you get this number? لا 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 بص, as I told you before, it's a very simple rule actually. In order to realize how, or in order to get how many lands do you have, look for the router ports. Look for the router ports. Okay, so let's look for where the router is. This is the router here. Okay, so the router has one port connected to this LAN and one port connected to this LAN. The other port طبعا is connected to the internet طبعا يعني the internet is not a LAN يعني this is the WAN. But you have one port here connected to one LAN and one port connected to one LAN. Okay, so you have two LANs. Okay, but on each LAN the level of sharing varies a little bit depending on whether you use a hub or you use a switch. I forgot to say that what is the level of sharing for the hub? A hub actually, unlike the switch, if we have the same example we talked about, okay, in the house, okay, and instead of using a switch, now we're using a hub, okay. So this hub, remember, a hub is a physical layer device. It does not have data link layer at all. It does not have any MAC layer أصلا. So a hub is a physical layer device, which means that it deals with signals and bits, digital signals and bits. It does not deal with any kind of frame structure. Okay, so it's as if we have a message coming to our house. Okay, but unfortunately, the guy who is responsible for delivering this message, he doesn't know how to read. يعني ما عندوش, he cannot read what the destination address is. So if the destination address says Amr, okay, it doesn't matter because this person cannot read. It doesn't matter whether it's going to Amr or Muhammad or Omar. It doesn't matter because for the hub is going to replicate this from the physical layer point of view, which means replicate the signal. Okay, replicate the signal to everybody in the house. Okay, so the only thing that the hub understands is just to replicate the signal on to everyone. Replicate the signal on all the hub ports. Okay, so how do you represent this in the logical topology? So in the logical topology, it's as if we have only one device. Okay, and this device is our house. So anything that comes to this house will physically go to everyone. So it's as if we all the house is represented using one node only. ماشي كده? So the switch is represented in the logical topology as a logical bus. The hub groups all the nodes in one node in the logical topology. Okay, because all these nodes will be connected from the physical layer point of view using the hub. Okay, and anything that comes to any of these nodes, it will go to all the nodes at the same time. ماشي كده؟ طيب, so going back to this activity بقى, So now we need to realize the logical topology that represents this physical topology. ماشي? So we need to look for where the hubs are and where the switches are, because both the hubs and the switch will go away. In the logical topology, the hubs and the switches, they will vanish. Okay? The router stays the same because the router is a network layer device, and it performs this logical isolation between the LAN. So the router will not vanish in the logical topology because the router is actually a logical device. ماشي? So now we need to show the graph that represents the logical topology that realizes this physical topology. So I'll give you 1 minute before we can solve it together. Man, go ahead. Okay. So one router كده and 2 bus. تمام. And these 2 buses are connected to the router. And what is the internet? Is also connected to the router يعني صح? Yeah. So this is the internet صح. ماشي. So far so good. ماشي. So on these buses بقى, what do we have? ولا انت خلاص وقفت على كده؟ So let's say this is logical bus 1, logical bus 2. ماشي؟ ها؟ طب ثانية واحدة بقى. Logical bus 1, we will talk about this LAN here. This LAN here. تمام. So here we have, طيب عندنا هنا mail server صح؟ This is the mail server and this is the web server and this is the file server. تمام. We connect them like this ولا ايه؟ نفس الايه؟ على نفس الباص we connect them individually ولا you connect them individually يعني we have another node here which represents the printer, another node represents the other nodes ولا ايه ازاي؟ لا that's wrong. These devices are connected using a hub. This is a hub. This is a switch. Okay? So a hub, as we said, connects the node in what way in the logical topology? هو احنا لسه قايلينها تحت يا عبد الرحمن ولا عبد الرحمن So the hub connects the nodes from which layer? It's a which layer device الهب؟ It's a physical layer device ولا data link layer device ولا ايه؟ الهب. لا. No. It's a physical layer device. It's a physical layer device, which means that the hub physically connects all these nodes in one node. Okay, so in that case, we will have only one node here representing the admin office. It's as if all these nodes, اللي هي الprinter and the 2 computers, they are connected as one node in the logical topology. Okay, so the admin office would be just one unit in the logical topology, just one unit. ماشي؟ طيب, what is in the logical bus 2? Logical bus 2 represents this switch. صح؟ انتريها. So here, ايوه. قول لي بقى. يعني I will have nodes تمام. classroom 1 classroom 2 classroom 3 to represent the 3 hubs اللي هم this hub and this hub and this hub. Okay, and these are in the logical topology this is one node. ماشي يا عبد الرحمن. عبد الرحمن تيسير صح؟ ماشي يا عبد الرحمن. So this is the logical topology that corresponds to this physical topology and it's one choice. يعني في الامتحان if you give me multiple choices for the logical topology it's wrong. I'm expecting one answer and one answer only. ماشي؟ طيب. So that's the difference between logical topology and physical topology and how do we represent the switch and the hops in the topology. So the last activity here talks about again the difference between the physical topology and the logical topology. So the rule here is simple. If the name indicates a physical device or a physical topology, then it's physical topology. Otherwise, it's a logical topology. بمعنى إيه؟ If the name indicates a method or a technique, okay, then it is a logical topology because again it refers to how we will share the medium or the media sharing. If the name indicates a physical يعني topology or a physical device, then it's a physical topology. So for example, Sysma CD, is this a name of a physical topology or a physical device or a physical medium? It's actually a method, right? It's actually a method, and we will talk about this method probably next time. So in that case, it's a logical topology, not a physical topology. ماشي? A star is a physical topology. Okay, a star is a physical topology that you can have like something like this and a star يعني everyone is connected to it. So that refers to physical topology. ماشي? So what about the contention-based access? Contention-based access here refers to a method. We will talk about how contention-based access works. So in that case, it's a logical topology. ماشي? A bus type. Remember, a bus by default is a physical bus. This is actually a physical bus. By default, if I say the word bus, it's a physical bus. ماشي? If I want to use it in the logical topology, then I have to say logical bus. ماشي? So a bus refers to a physical topology. Sysma CA is a method like Sysma CD here. We'll talk about the difference between the two, in which case it's a logical topology. Controlled access is also a method which counters the controlled access, the contention access, sorry, or contention-based access. We'll talk about both. So it's actually a logical topology. Point to point, again, we have logical point to point, but I have to say logical point to point. But by default, point to point refers to a physical topology. Ring also, we have logical ring, but if we say ring like this, then we have to consider it as a physical topology. Hub or Spock, this is actually the physical topology which is used. No, this is physical topology which is used for connecting routers in WANs. Okay, so if you want to connect multiple routers, then you use what we call hub or Spock to connect WANs together. Yes, like different cities or different routers or different geographical locations in general. يعني. Maybe different geographical locations in one city. ماشي? So in other words, it's a physical topology, not a logical topology. ماشي? And the mesh, again, we have logical mesh, but by default, it's a physical topology. So in other words, if I want to use the one of these names in the logical topology, then I have to say logical bus, I have to say logical mesh, I have to say logical ring, and so on. Okay, but by default, if I say the word ring, we mean physical topology. ماشي كده؟ Okay. Any questions يا شباب؟